Estimation, Chapter 9. Let's recap an old problem using z-scores. Let's find the z-score in a normal distribution that cuts off the middle 90% of all z-scores, the middle 95% of all z-scores, the middle 99% of all z-scores. So we've done this before in Chapter 7. The tool that we use to find the z-scores on a horizontal axis where we're given a piece of area is IMV norm, inverse normal function. We're going to find the z-scores that cut off the middle whatever percent, which means we're going to find two z-scores, one on the left and one on the right. And we're going to round these z-scores to 2 decimal places. So this is an image of the middle whatever percent. So suppose we're looking at part A, the middle 90%. This piece of shaded area represents 90% of the bell curve. And what we're asked to find is the z-score on the far left that cuts off the bottom unshaded tail from the middle shaded area, and the z-score on the right here that cuts off the middle shaded area from the top unshaded tail. So to find these two z-scores, we have to use IMV norm, and we're going to involve the area to the left of that unknown z-score. So for the middle 90% of all z-scores, we have to realize that 5% of the area falls in the leftmost tail. Because this is middle 90% and we have symmetry with the bell curve, it means that 10% must exist in both tails, and because of the symmetry, 5% must be in one and the other 5% must be in the other. So knowing that 5% of the bell curve lies to the left of this unknown z-score, we're going to use IMV norm and we're going to put in area to the left as 0.05. Okay, so our area to the left is 0.05, our mean is 0, our standard deviation is 1, and we get a z-score of negative 1.64. So let me just verify how we do this on the calculator. Let's go into our calculator, going to the IMV norm function. Remember where that is. IMV norm is in second DISTR. Okay, so second DISTR, IMV norm is number 3. Area to the left we're going to put in as 0.05. The mean is 0, standard deviation is 1. Paste it. And we have rounded to 2 places, negative 1.64. And the last thing I wanted to state in this slide is because the bell curve is perfectly symmetrical with respect to z-scores, because we have negative z-scores on the left side of center and positive z-scores on the right side of center, the z-score on the other side that cuts off the top unshaded tail from the middle 90% must be positive 1.64. So we have a negative 1.64 on the left side and a positive 1.64 on the right side. So the two z-scores that cut off the middle 90% of area are negative 1.64 and positive 1.64. Let's go to part B, where we find the z-scores that cut off the middle 95% of all z-scores. It's the same kind of problem, but just different numbers. So if we note that this is 95%, then how much of a percentage must be in the left tail? Well, if this is 95, then the remaining unshaded areas left and right tail must be 5%, and because the bell curve is symmetrical, this piece of area on the left side, unshaded, is 2.5%. So to find this unknown z-score that cuts off the bottom 2.5% from the top, we just simply put into IMV norm 0.025 for area to the left. So 0.025, the mean is 0, standard deviation is 1, and when we do that on the calculator, we'll get a negative 1.96, and by the same concept as the previous slide, the z-score that cuts off the top unshaded tail from the middle 95% must be a positive 1.96. So we have a z of negative 1.96 and a z of positive 1.96 cutting off the middle 95% of area. Now that should make sense because the middle 95% of area is a bigger piece than the middle 90% of area, and so our z-scores are going to spread out further away from center and therefore get further or closer to further down on the left and further up on the right. So hence we see the greater negative number and the greater positive number as compared to negative 1.64 and positive 1.64. So we're going to do it one more time with a middle 99% of z-scores. So we note that this is 99% of the area with a remaining 1% existing in both unshaded tails. So in this left unshaded tail we must have 0.5% or 0.5%, which means that the area to the left of this unknown z-score is 0.005. when expressed as a decimal, 0.005. The mean is 0, standard deviation is 1, and that gives us a z-score of negative 2.58, which means that the z-score on this side, on the positive side, must be positive 2.58. Okay, which makes sense now also because 99% of area, a bigger piece of area than 90 and 95, therefore our z-score is getting more negative on the left and our z-score is getting more positive on the right because we are being pushed out further on the left hand side and pushed out further on the right hand side. We are going to use these z-scores later on in a formula, and that's why we started the lecture with this exercise, because we are going to use these in a moment.